Hello students, and welcome back to another world history lesson. Again, my name is Mr. Willis, and you're listening to this lesson because you're a student for me or for Mr. Gordon or for Miss Pancini or Mrs. Atwood. And this lesson is going to focus on the scientific revolution and what the scientific revolution really brought for us to this world. A lot of it was predicated on the events that were surrounding the Enlightenment, and prior to that, the Renaissance, exploration, so on and so forth. So exploration had a lot to do with it as well. We're going to talk a little bit about exploration today in the video, and I'll get to that here in just a second. But first and foremost, you guys see a picture of our solar system here in the presentation. And obviously, the scientific revolution plays a major role in we discover the solar system during the scientific revolution. Okay, thanks to people like Nicholas Copernicus, Johannes Kepler, Galileo Galilei, Sir Isaac Newton, just to name a few people that are really important during the scientific revolution. Especially when it comes to the laws of motion and the motion of different celestial bodies, such as the planets, and so on and so forth. And if it wasn't for the work of these men and some women, we wouldn't probably have started at an early time to discover the different facts about the solar system that we know today. So it's a controversial topic just because during the time of the scientific revolution, religion was very prominent, and it created this controversy or this conflict where do we believe in God and the solar system being a part of that equation. We know if you're very religious that God created the universe in 7 days, 6 days really, 1 day to rest. And sometimes the science books tell us that the solar system was created by this Big Bang. So which one do we believe? And so the lesson really is, here scientific revolution plays a major role because we try to use science and the scientific method, which we'll talk about today as well, to gather evidence to prove which is true. And so we really push our students to try to use factual evidence, conduct experiments, just like in a science class, in order to discover what the true answer is. And so that's the basis of any educational class, whether it's advanced placement or a college prep class. We really want you to use your opinion backed by factual evidence to prove what is true. And that's really the basis of the scientific revolution. How can we experiment with different things and use facts, use data to prove what is true and what isn't true? Now, what's ironic about this first picture in the solar system is that even before the scientific revolution, much of the data that was driven in terms of discovery was based upon mathematics. Now, again, you think of the solar system, we think of geometry, we think of circles. So they were on the right track before they began to really find a lot of data outside of what the norm was by using mathematics as a basis for discovering information, discovering facts about the world and the universe that we live in. And so we're going to kind of go into this first slide here that we have beyond the solar system slide. And it's a slide I like to show to my students. This happened 8 years ago, where the space shuttle Endeavour, after its final flight for NASA, was flown out to Los Angeles International Airport. And you may be old enough to remember, probably in elementary school, seeing the Space Shuttle Endeavour fly over, and maybe even you were lucky enough to have your teacher go out and show you that, because I specifically remember it flying over or near Villa Park High School, and it circled around Disneyland for sure before it landed at Los Angeles International Airport. Now, what's the significance of this? Well, the Space Shuttle program was around for 30 years. And for that time of 30 years, from the 1980s, during basically the Reagan administration, all the way through the Obama administration, the Space Shuttle, over time, developed more and more complex missions. So from just taking, the first time taking 2 men up into outer space, in the Space Shuttle, and the first reusable aircraft, reusable spacecraft that we had in our nation's history, to taking up satellites, to, in the last several years of the existence of the Space Shuttle, it took up segments of the International Space Station. And we recently saw, just last week actually, the successful flight of SpaceX capsule, which actually ironically was named Endeavour, which landed in the Gulf of Mexico and was successfully retrieved with 2 astronauts on board. And those 2 astronauts on board both were astronauts who had flown on Space Shuttle Endeavour. So really cool, interesting connections between the solar system and the NASA organization, as well as the Space Shuttle, and being able to travel to outer space. So before we talk about Johannes Kepler, probably important that we briefly talk about a predecessor of his that we don't have a slide for, but still plays a really important role in the scientific revolution. And his name is Nicholas Copernicus, and you probably heard about him. Nicholas Copernicus is the first to use a telescope to find the movement of the planets in the universe, and he uses observation, obviously, to do this. He uses his notes to pass this on to future generations like Kepler, like Galileo, who we're going to talk about here in a few moments. But basically, Copernicus is the first person to bring up the idea that is contradictory to what the Catholic Church had been teaching its people, its parishioners, for hundreds of years. Copernicus found evidence that the movement of the planets seemed to suggest that rather than the Earth being the center of the universe, which is what the Catholic Church had been teaching, remember, most people were educated by clergy. So they were teaching that the Earth was the center of the universe. Copernicus actually had evidence that the planets were circling around the sun. So the terms that we would use to describe that would be geocentric. Geocentric means earth-centered. That's the Catholic view. Heliocentric is sun-centered, which is the Copernicus view of the universe. And so he's the first to find evidence that it may not be the Earth that the universe is revolving around. It's the sun. But his belief was that the planets were revolving around the sun in a circular motion. It's going to be Kepler here on this slide that actually takes the information from Copernicus, actually disproves what he says, right? He finds evidence that they're not doing a circular motion. They're actually doing an elliptical motion. And again, they're both doing this through observation, through use of telescope. And you have to think that over time, the telescope is getting to become better. It's evolving. They're making better ones over time. And Kepler uses mathematics, just like any scientist would do at the time. They're going to use mathematical equations to find the answers to the universe. And it's his belief through mathematical equations and through observation that the planets are actually moving in an egg-shaped formation, an elliptical formation, rather than a circular formation. Right? So Kepler is really building upon he's building upon Nicholas Copernicus's idea, but he is refuting it. He's actually saying he was right in some ways, but in some ways he was wrong. What he actually is proving is that the planets move in an elliptical orbit. Now, that takes us to Galileo. Galileo, who was a Catholic, takes Kepler's ideas and does more observation of his own, writes down information, takes his studies and publishes it, knowing that it is against what the Catholic Church had been teaching for hundreds and hundreds of years. Well, this gets Galileo into a little bit of trouble, because since this information is being published for people to read, Galileo is now called to a Catholic Inquisition. Basically, he's called to go before a judge and jury of Catholics, Catholic clergy, in 1616 to answer for his publication. And they give him an option. They tell him, they threaten him, they say, we're going to torture you, and even worse, we're going to excommunicate you from the Catholic Church. Think about that. Excommunication basically means they're going to kick him out. I want you to think about, if you're religious, I want you to think about your faith. His belief is that salvation through God, one day when he dies and he leaves the confines of his body, he's going to be with God in heaven. His soul will be with God in heaven. And if he's excommunicated, that can't be possible. So he has this internal conflict. Does he believe his scientific proof and stick with it and risk losing it in the afterlife and being with God? Or does he give in because ultimately his faith is the most important? Well, he gives in. He doesn't want to die, and he doesn't want to be tortured. So that's not really an option for him. So in 1616, he reneges. He says, I was wrong. Well, in the 1990s, under the papacy of Pope John Paul II, the Catholic Church issues a public apology to Galileo some 300 plus years after the death of Galileo, saying that Galileo was correct. He indeed had the right information, and the universe was heliocentric. I want you to think about that. It took him 350 years to admit that Galileo was correct. So 350 years before his time, so to speak, Galileo knew, with the evidence from Kepler, with the evidence from Copernicus, he knew that what he was saying is accurate, and he published it. Our next scientist to talk about is Sir Isaac Newton, and he's probably most well known for the apple falling and hitting in the head story. But yes, gravity is really what his claim to fame. However, he's known for something else that maybe not a lot of people know about, and students in particular may not like. He invented calculus, and that was his first claim to fame. So it tells you a little bit about Sir Isaac Newton. Again, he falls in line with Copernicus, with Galileo, with Kepler. His work is a culmination of that. But mathematics, the use of mathematics in scientific discovery is huge. And Sir Isaac Newton, it ends up leading to his discovery of calculus, or his invention of calculus. The big thing is his 3 laws of motion. Basically, that, if there's a force that makes something move, there's going to be an equal and opposite reaction to that. So Sir Isaac Newton, his 3 laws of motion, his invention or his discovery of gravity, and his invention of calculus are really his claims to fame. Now we're going to talk a little bit about the scientific method, and again, this might be a refresher course for you because if you're taking a science class, you probably already know this. But there are other scientists who don't necessarily agree with Copernicus, who don't necessarily agree with, Galileo. But the scientific method basically is the true form of being able to discover or to be able to gather information. Again, number one, the procedure follows that you use questions that arise through observation to find a conclusion, and your conclusion is your hypothesis. So you can reasonably conclude that something is going to occur based upon your observations, and this is what Copernicus did, Galileo, Kepler, Newton. They had something happen, they observed it, they wrote down their questions, and then they began to write down the bits and pieces of it. This is what we call deductive reasoning. You're going basically, you're finding a conclusion to the problem. Okay, so you take data, you analyze it, you interpret it, and this allows you to be able to find an answer to the equation that you're looking for. And so you're using a reasonable assumption that what you're saying is true, and you're using data to prove that it's true. And that's basically what you do in history. In history, you're going to take events, you're going to look at them, and then you're going to say to yourself, what do you think is logically the next step that's going to occur? All right, and so that's what we have with the scientific method. Sir Francis Bacon is another scientist that we want to briefly talk about here. And his steps are what we call inductive reasoning. So basically, he wanted to go from a broad subject to a much more narrow answer. And so in doing that, his big belief was that if we could just learn, if we could educate ourselves on practical knowledge, what are the basics, we can improve people's lives. And so, just being able to learn, basic understanding of survival, basic understanding of health, basic understanding of how a body works would be important in preserving lives, allowing us to live longer. Scientists should use experiments, gathering information, drawing conclusions about the world. Okay, finding out, how does blood flow in a body? Okay, this was a big part of that. William Harvey was the one that discovered the heart was the center of the blood pumping in a human body. Before that, people believed that the liver actually pumped the blood, right? And it wasn't until we actually conducted experiments on people who were dead, scientific experiments on cadavers, that allowed us to be able to find out, well, the heart was actually the one that was pumping the blood throughout the body, not the liver. So, it's this ingenuity by scientists that allows us to be able to find the answers that we are looking for. Using the experimental method, empiricism, is really important to be able to gather information, to experiment on it, and then to draw conclusions on it. It is necessary for us to, in a way, have like internships in different areas for us to understand how it's done. When I was a kid, my dad said the only way you can learn things is by doing it. The only way I know how to change the oil in my car or change the brakes on my car is to actually do it. I had a roommate in college that I learned how to make a computer, and I watched him do it. So the only way you're going to be able to learn things is to watch and learn and to experiment with it. So it's really important that we're able to do that, having practical knowledge to be able to do it and then actually put it into action. Now, our last person that we're going to talk about here is Rene Descartes. And Rene Descartes, who is, again, another big mathematics guy, bringing us algebra and geometry. Really important to the mathematical sciences that we have today in school. Basically, let's take knowledge, let's take logic, let's take math, and that's how we're going to gain knowledge throughout the world. That's the only way you can do it. And he's what we call the the father of modern rationalism. So just think rationally, use your logic. What are the logical steps that we have that would conclude us to believe that something is true? And we're really getting away from these earlier times in modern world history where faith was guiding us. That was the guiding light in people's lives. And unfortunately, the Catholic Church, as I've discussed in previous lectures, had series of corruptive popes that really turned people off from what this habit was, that people just believed what was being told to them. And now all of a sudden people are now experimenting. They're using their own brain. They're reading scientific journals if they have the ability to do that. And they're really beginning to experiment on their own, and they're coming up with conclusions that wouldn't have been found unless they did it on their own. So observation, the scientific method, forming a hypothesis, using data to prove it. All of our scientists that I've covered throughout this lecture have done that, have used that particular method to prove something true. And so the scientific revolution really is this turning point in modern world history where people begin to use their own discovery of knowledge, their own logic, to be able to find the answers on their own. And that's really important that we continue to do that as we move further and further into the 21st century. Again, if you have any questions, we're here for you. All 4 of your world history teachers are here for you. We hope that everything's going okay, and that the distance learning model is a little bit easier with these lectures. And as always, don't be afraid to reach out to us either through Remind or through email, and we'll be happy to answer any questions for you. Until our next lecture, take care, students.